To start this off, we're going to start with what we know. Okay? Let's start with what we know with adding integers. Okay? So when we had something like -6 plus 4, who can explain to me what the answer is and kind of how we justified what the answer is? So what is the answer to -6 plus 4, and why is that the answer, Maria?
It's -2 because you just do 6, well, a negative plus a positive subtract, and since 6 is bigger than 4, it's
All right, we talked, they throw down, 6 wins by 2, right? Gets to keep its sign. Everybody kind of good at that? What does one positive and one negative do to each other? Cancels each other out. So that's kind of the premise I take in all of this, all right? And so, who can explain what was going on when we had something like this? -7 plus -3. I'm going to rewrite that. James? They're hugging, which means my answer is? What's my answer?
-10.
Yeah. So 2 negatives made something more negative. So when subtraction happens, it has the potential to get a little tougher. But we're good because I'm going to show you something pretty cool. So you're going to look for patterns in what we're doing, and then you're going to extend the pattern. Okay? So we're going to start nice and easy. 5 minus 5 equals 0. 5 minus 5 equals 0, okay? I'm going to do one more with you, and then I'm going to set you free at your table groups, okay? 5 minus 4 is 1. So when I subtract by number less, right, 4 is less than 5. When I subtract by one number less, what's happening to my answer? My answer gets one number higher. So I want you to extend this pattern that far right now, just at your table group. I know it's going to seem, this is intentional, very intentional. So if it seems easy, that's okay. Just stay with me. So Sean, what'd you get for 5 minus 3?
2.
Then what?
3.
Okay?
4.
Okay?
5.
So, like, without even me setting up the next problem in our pattern, what would the next answer be?
It would be -1.
No, look it. No, the next answer. So this number right there. 0, 1, 2, 3, 4, 5.
It would be 5.
0, 1, 2, 3, 4, 5.
4.
6. And if the pattern holds true, the thing that would be next is 6. Everybody seeing that? So as I'm subtracting by a number that's less, my answer is going up by 1. That would have to go up by 1, right? So that number less would be 5 minus -1. If I kept my pattern true, if I went 1 less than 0, then I'm going down to -1. Everybody follow that pattern right there? So next, one more down from minus -1 would be 5 minus
7.
-2. And the answer to that would have to be
7.
7. So let's focus on this. All we did was extend a pattern. What's another way with a 5 and a 1 we can get 6, Brayley?
5 and a 1?
Yeah, what's another way with 5 and 1 we can get 6?
5 plus 1.
Okay, so I'm going to write that off to the side in another color. You might not have another color, but... So what we're saying is these two things have the same result. Let's see if it's true for the 5 and the 2. 5 plus 2 equals 7. So what do you notice about those two expressions? 5 plus 2 and 5 minus -2. What do you notice about those two expressions? They're the same. So minus negative just means what? Just add it. Add the positive version of it, right? Are you guys seeing that? So here's the reason I like running this experiment. A lot of you probably did subtraction where there was a minus negative last year, and you didn't really understand why you were adding. Is that true for anybody? Nobody? Everybody understood? Because if you did, that's awesome. I love that. I'm not getting feedback either way. So let's just do hand raise. Who understood why things were getting larger when they were subtracting negatives last year? Who understood why? Okay, and who didn't? It's good not to understand. Like I teach this class every year, and a lot of people don't. Yeah. So if you didn't understand, this is why. The other reason why is, what direction does a negative send you on a number line? Left or right?
Left.
Left. And then what direction does a negative send you on a number line? Left. Can you get sent left twice like that in one operation? No. So what happens is one of those reverses which direction you go. So you're actually heading right on a number line, which is positive. So the reason I want to front load with this is when we look at some problems together with subtraction, I look at them a little different than you might be used to looking at them. So let's start kind of nice and easy with a nice 6 minus 4. So I know this is like, you guys are like, why are we messing with 6 minus 4? It's because I'm going to explain to you how my mind thinks of these numbers, and then we're going to apply it to more difficult things in a second, okay? So when I see 6 minus 4, here's what I see. I see 6 positives, and I see 4 negatives. And the reason I choose to look at it that way is, once I identify these numbers as either positive or negative, do I need to think about this any other way than addition? Do you think I need to think about it any different than addition once I identify if it's positive or negative? No, with addition, we identified when they were the same thing, it got bigger, they hugged, and when they were different, they threw it down, and only one could win. So once I identify this as a positive 6 and a negative 4 like so, what's the result? Positive 2, just like, so you know 6 minus 4 is 2, but do you see that that's actually the same thing as we were doing the other day with a 6 plus negative 4? I'm going to challenge you. A lot of teachers do the keep, change thing. You guys do? Some of you have done that. You can do that. But what ends up happening is some kind of procedural error sometimes. You can do less work. You don't have to do keep, change. If you understand, is my number positive or is my number negative, and how do those two things interact? So let's do one that's a tad tougher, and I'm going to challenge you to think of it like I'm saying. Is it positive? Is it negative? So negative 6 minus 8. So if I'm looking at these numbers and trying to decide positive or negative, is that 6 positive or negative? Negative. Is this 8 positive or negative? Well, a minus 8, which direction does that send you on a number line? A minus 8. Left. So that 8 is negative. Right. Left, right? Yeah, it's negative. So, instead of changing anything, I see 6 negatives and 8 negatives for a total of 14 negatives. Now, I don't end up writing these circles every time. I'm writing them on here to kind of show you like what I'm seeing. All right? But some students I do have choose to write the circles. You don't have to change anything. Once we identify, is it positive or negative, and how do those interact? So let's look at another one. Let's do 4 minus 12. 4 minus 12. So help me out here. Just say it out. Is the 4 positive or negative? Positive. Is the 12 positive or negative? Negative. And so they throw down, right? And that 12 wins by 8. So once, again, I'm trying to train us so that we're not thinking of anything different than we've already been doing. It looks different because of subtraction, but really subtraction and addition are the same thing. It all depends on it. Because some numbers that are positive become negative, some are negative become positive. Let's slow down and just identify what's what, and then use what we know about how numbers interact. So here comes the little bit tad trickier one. You ready? 6 minus negative 2. That's where it gets a tad trickier. I don't mess with anything. I don't do keep, change myself. I look at the 6 and I say, is that 6 positive or negative? Positive. And then I look at this minus negative 2, and is that positive or negative? That one's positive. You can't be negative twice. That one's actually positive. So 6 positives and 2 positives, they hug it out, 8 positives. Right? So a way to remember that double negative is, anybody ever take a language arts class before? A couple of you? Everybody? Hopefully? You were there at least, right? What happens in your teachers? They're not cool with double negatives. Is that true? In language? Do you know why they're not cool with double negatives in language? Because if you don't have no paper, then you have to have some paper. Because the double negative makes it positive. That's why we don't use it in language. You guys follow that? If you don't have no paper, you have to have some paper. Okay. Same thing in math. That double negative makes it positive. Okay, let's look at the one last hardest example. Okay? Negative 4, I'm liking the 4s today for some reason, minus negative 7. Negative 4 minus negative 7. So help me identify positives or negatives here, all right? This negative 4, positive or negative?
Negative.
Okay, this minus negative 7, positive or negative?
Negative. Positive.
Yeah. So are they hugging or throwing down?
Thrown down.
They're throwing down. Everybody should hug, but numbers don't. Numbers are different, right? You should be nice to everybody. Integers, they're a little different. Okay. So who wins, the 7 or the negative 4? The 7 wins by 3. Again, we don't need to retrain our brains at all from addition. It's the same thing. Subtraction is addition. Addition is subtraction. That all gets confusing. I'm trying to simplify and say, let's understand if the number is positive or negative, and how do they then interact. You feeling me on that being a little simpler? I'll let you know, sometimes kids trying to change the switch, keep, change thing, they'll struggle at first, but I'll let you know that when I give like the test after the quiz, like 2 assessments from now, and there's some of these on there, you're just like better at it. You'll be better at it. Like, I don't have to reteach it over and over. There's no struggling trying to remember rules. If we understand what's positive and what's negative and how they interact, we're good forever. You never lose it, all right? I promise you. Cool? Cool.